Okay. So the question is, if you're on a online homework question, and you've gone through the helps, you've gone through the help me solve this, show me example, then use that ask my instructor button, and that will send an email directly to me. And if you've done some of the problem, it'll show me what you've typed in, and I can sometimes I get diagnosed from that. Um, it seems a really common thing. Like I had one yesterday that I sent out. It was doing the standard deviation for a frequency distribution, which is really kind of tricky. And to do that in StatCrunch is kind of tricky. So there's a specific video for that problem in Blackboard. Obviously, some people don't see it. It's in that section. There's two videos there. So sometimes it's as easy as, oh yeah, I know this problem it's hard. Here's the exact resource that I'll point you to, and then use that will help. And then if that's not helpful, then I can follow up with some more things. But that seems to work most times. So if don't sit there and beat your head against the wall. Hit the Ask My Instructor button, and then that helps me find the right thing for you. It'll save you a ton of time. Um, so yeah, don't be bashful about hitting that thing. So who's taking the test yet? Anybody? I'm guessing you
I,
haven't.
I haven't started it yet, no.
Oh, cool. So I think I've graded everybody that's submitted so far. There's some very, very good grades. So I can tell the people that have gone through some of the tests from previous semesters and practiced and spent some time doing that, they're usually more than fine. So that's why I really encourage you, if you could get all of your Chapter 3 online homework done and your discussion for Chapter 3 done by today, so then tomorrow all you had to do is kind of review and take the test, that would be great. You do have a 2-hour time limit, but my guess is most people take about an hour is all it requires. It's plenty of time. Then you got plenty of time to use your Adobe Scan and take pictures and submit them, email them to yourself, submit them through Blackboard, all that good stuff. So make sure you got enough time to get all that done as well. And that's why, did you all do the practice uploading a document assignment in the Start Here folder? Did you guys all do that?
Yes.
Okay.
Yes.
So awesome. All right. So that gets you some practice. That's really all you have to do. So it's kind of nice when it's all one PDF file. It's much easier to grade. And I do have multiple file attachments just in case you just needed to use images or something. But typically, students have been doing very well getting it done correctly. So somebody did comment the other day that they did their test and they submitted it, but they had no record of it. And for some reason, it just doesn't send you an automated email that they've received it. There's not a lot of strong indications. So I would say, if you hit the submit button, trust that it's submitted. And if there's something wrong, I'll contact you. But a lot of people are like, and I understand, they're like, well, I hit it, but I didn't get any indication. So here it is again. So then I get 50 emails. Well, maybe not 50, but a lot of emails that are like, here's my test again. I'm like, that's cool, but I'll let. So I mean, it's not a big deal, but it's trust that it's going through. It seems to work every time as long as you hit the submit button. It's there. So all right, so I'm gonna just go down the list. So I just kind of gave some general stuff there. And Alejandra, you were here first. So did you have a specific thing you wanted to go over from that homework, or it was on standard deviation? Is that what you were asking me about?
I think so. I think it was standard deviation, but no, I just wanted to kind of go through the discussion board and stuff, what we have to do tonight.
Yeah.
Kind of go through that.
Is that all right? I'm going to do that right now. I'm going to go ahead and share my screen, and I'll just kind of help you get started, kind of thing, And let's do this. And can you all see that?
Yes.
Okay. So I'm going to go into chapter 3 here, and I'm going to go down to the discussion. That one folder that one video I was telling you about that really hard homework, it's in section 3 too. It's this one right here. Summary statistics with a frequency distribution. Definitely going to watch that minute 45 video.
Yeah, that was not easy to do.
No. if you watch this video, then to figure that out on your own would be extremely hard.
Yeah, that video very helped me a lot. So
yeah, I just strongly encourage everybody to do that one. It'll save you a ton of time. And then this is like some how to calculate standard deviation. These are more kind of like conceptual ways, and it does kind of go through the formula. But in general, we're just going to use StatCrunch to calculate the standard deviation. It's a measurement of spread. So standard deviation, if I got a data set and it's 3, 3, and 3, well, the mean is 3, the median is 3, and the standard deviation is 0. There's no spread. So the standard deviation is a ruler or a measurement of spread from the middle. And in general, it's kind of like the average distance data is from the mean. It's not really that, because it uses like the quadratic formula really to find the distance. But that's probably beyond what you need to know. But it's a good measure of how spread out the data is. And so if we go down to chapter 3, semester project, hopefully you have your data that you gathered from the discussion last week. And what they're asking you to do here is to, find the mean, median, mode of their weights, I think. And then you can do that on Excel or StatCrunch, whatever. I would encourage StatCrunch. Just load your data in there and crank it, do your 5-number survey. Most people don't have any problem with that. But what they do have a problem with sometimes is the Z-score thing, and then finding the percentile rank. So the Z-score is you just pick a famous person. For some reason, it seems like a lot of people pick The Rock, so because he's heavy. What did somebody pick today? Somebody picked Shaq today in one of theirs. He's pretty heavy. So anyway, you take that weight minus whatever you got for your average for your sample, and then you divide it by the standard deviation that you got for your sample. So it's kind of using your data set as a measuring stick, and you're comparing this person to it. So the top is just like how far away from the middle is it, and S is standard deviation. It's like how many standard deviations are they away. And that Z-score is a standard score that describes is it above, is it below? So if it's a negative Z-score, it's below average. If it's a positive score, it's above average. And we're using the rule. It says here, it asks you if it's, kind of statistically significantly high or low. And at this point in the course, we're just using, is it more than 2 standard deviations? If it's less than 2 standard deviations, we're like, okay, yeah. And if you've gone through the empirical rule, we know that about 95% of the data in a normally distributed set is within 2 standard deviations. So what we're looking for is, does someone have an extremely low or extremely high weight that puts them in the margins, like the bottom 2.5% or the top 2.5%? And that's really all we're doing here. And then we get to use the normal calculator. And I might just pull that up really quick here. I'm just going to pull up one of the assignments. And we'll just kind of do an example really quick. I think I can just pick any one of these. I think I can get to StatCrunch through any homework problem. That's another way to get there. Yeah, StatCrunch, here we go. So I'm going to go ahead and load the standard normal calculator, stat calculators normal, and I would strongly encourage you to use this for everything you do with the normal distribution. See, the standard normal has a mean of 0 and a standard deviation of 1. And what percent of the data is below 0? Well, it's half the data. Now, a lot of people have been putting in the mean for their sample, the standard deviation for their sample, and the weight of the person. And that does work. What I'd rather do is let's start thinking more about, okay, regardless of what your sample is and what somebody else's sample or my sample, regardless of what that is, the Z-score standardizes it. It doesn't matter what the mean and standard deviation are. It tells us how far away from essentially the middle something is. So let's do that. Let's just say the average for my sample was 180 pounds and I weigh 200 pounds, and the standard deviation is 20, so I'm 1 standard deviation above normal. Then I could just do this. I could just put 1 and compute, and that means I would be in the 84th percentile. So you can, and this is better to start using the standard normal calculator this way, because when we get into chapter 6 and beyond, we're going to get z-scores, and we can't necessarily, and we're going to be studying not just one person, but groups of people. And the standard normal calculator can help us with, as long as we got a z-score, we can just type it in. So let's say I was 160 pounds. That would be -1 standard deviation. Boom. Or whatever it ends up being. And so when we get into chapter 6, we're looking at group means. There's no way to put in the size of the group here with this calculator. And that doesn't matter if we have a standardized score, a z-score. So that's why I'm encouraging everybody to, use mean for the 0. Standard deviation is 1. That's the standard normal distribution. And if you've done the empirical rule, we know about, here, I'll hit the between button. We know that about 68% of the data is between -1 and +1. And I'll do -2 and +2. Compute. And there's about 95%. It's called the empirical rule. And then if we go 3 standard deviations, that's going to be 99.7%. Almost everybody is within 3 standard deviations of the mean, typically. If someone's beyond that, like Shaq, that's very rare, right? So there's a brief overview of how to use that. My encouragement to use the standard normal with mean 0, standard deviation 1. Let's go, yeah, and then we can actually change the inequality if you want to go above or below and all that stuff. So I just suggest just playing around with this calculator. So what do you all think about that? Let me stop sharing for a second. Questions on what I just said there? Is that rehash or is that new, any of that?
No, I think that covers it. I think I understand more how to do that.
Okay. Yeah, I mean, and that's the good and the bad is you can use that calculator. If you just put in the mean, the standard deviation, and the person's weight, it'll do it. Unfortunately, we're going to be moving more into just using z-scores than specific raw scores for different sets. The z-score works. So for instance, you've got an ACT and an SAT score. You could compare them apples to apples if you know how many standard deviations above and below someone is from the mean. It doesn't matter what the scale is. It matters how far away from normal are they, and the z-score tells us that. So that, and I would, when you take your test, have that calculator open, ready to start using it. You don't need it to do the test because you can just use the empirical rule, like what I just showed, but it's handy, and I just encourage you to start using it. Rather start using it now, and because we're going to use it the rest of the course.
Can we use our notes question on the test?
Yeah, it's essentially open note. It's open book. So it's essentially it's like a 2-hour take-home exam. The other thing I don't want you to do is phone a friend. So just do it independently, and it's free response. So like especially in the spring and the fall, I teach a couple sections of high school sections, and there's a few kids at schools, and about once every 2 to 3 years at a school, I'll have some people that'll copy off each other, and then I have to make a really bad phone call and go, yeah, well, one of you was probably the lead and one was probably the follow, so who was it? And they're like, well, how do you know? I'm like, because you had the exact same wrong answers, and that's really weird, especially what you guys wrote. So it's pretty easy for me to kind of pick it up. But usually students, honestly, I used to have all proctored exams. Pandemic hits, no more testing centers. We don't have a software system that really can make it happen officially anyway. So honestly, my scores have almost stayed exactly the same. And I've seen not a lot of students get, that big a difference. So I've been pleasantly surprised. You have the same chair as my son, I think, too. I swear he's got that in his room right now. That's kind of it's a gaming chair, right?
Yeah, it's a gaming chair.
Yeah, it looks.
I just like it for the back and the neck support.
Yes.
It's like a little back and neck pillow. Helps out a lot.
Okay, that's pretty cool. He's really good at games. He's a computer engineering major. He likes it, so yeah, he's going to be a junior at Iowa State. So Anyway, that's a great question. Alejandra, thank you for that. And then I'll go to Rachel next, since you were second. Rachel, what are you interested in kind of discussing more?
I was really hoping to go over the first practice test that was on Blackboard.
Sure. I'll go ahead and pull it up right now. Was that the 2020 exam?
I believe so, yeah.
I think so. Let's see here. Chapter 1 through, there we go. In fact, I'm gonna pull the one up with the solutions, if that's okay, just to make it easier. There we go. It's working. All right, do y'all see that now? And yeah, this is 2020. You can, if you go in the upper left-hand corner, there's like a magnifying glass. You can make it bigger so you can see it better. Is that helpful? So did you want to just kind of go through the whole thing? Did you want to go through certain parts? I'm up for whatever.
I would prefer the whole thing, but we can do parts. It doesn't really matter.
It doesn't take that long to go through the whole thing. And if you watch my solutions videos, you kind of can see that it's not, I mean, if we're just going to generally talk about it, but some of these are more tricky than others. And how about if I just look at the things I'm really looking for? Is like on this one, on number 1, it's trying to say, is it essentially, it's asking the question, is it statistically significant that, you know, the claim is true here, or what they're saying the alternative is? It says yes, the probability of observing this is less than 5%. So that's kind of our threshold, and we'll be talking more and more about this. But so if something has the probability of happening less than 5% of the time, we start thinking, well, we observed something kind of weird. Maybe something weird is going on, or something different than I thought. So whenever you get a probability, if you observe something that happens a low percentage of the time, that's a warning that maybe something has changed or different. And this idea of how do you select your sample is important. We obviously want a random because it reduces bias. There's a lot of surveys have what we call a voluntary response bias. Only people who really care respond, which means they really, really aren't positive, or they're really, really negative, and you miss all the people in the middle. So it's better at best you can to have a random or systematic way of selecting the sample to make it representative. And this idea of reducing bias is the key. Number 2 here, unfortunately, some students still miss this, and I hate grading them. I ask a question on this year, on the one you're going to take, that's a little more, well, if you get the wrong answer, it's worse. How about that? We want to do ideally, we'd like to do experiments, right? So, because we can have a control group, and then we can manipulate a variable and see if manipulating that variable causes a difference, yes or no, like weight loss or something. But if I'm going to do an experiment on something that, well, here's the one we saw at our stats conference a couple weeks ago at Iowa State. It was a cartoon, but it showed a bunch of people jumping out of an airplane. Some had parachutes and some didn't. So one would be the experimental group and one would be the control group. Obviously, we have not experimented like this because that would cause harm to people. So same thing with smoking. We don't really experiment with smoking. It's not like we get a bunch of 2-year-olds in a room and say, okay, you all going to be smokers and you're all not. We'll see how this turns out. That's unethical. So we can't do experiments on anything. So we don't want to cause harm to people. So a lot of times we just use observational studies. So we just look at existing data sets and see if we control for certain variables, what's going on. And then, yeah, so the difference in experiment is you manipulate variables. Observation is you're not changing anything, you're just observing what has happened. How's that? For the first 3, is that okay?
Yeah, thank you.
Okay. Number 4 is always a little tricky. So it's like that 5-number survey kind of stuff. What happens if I add a data point? And what you want to make sure is you read the question carefully, and they'll be like, is it for sure going to change? Might it change? Stuff like that. That verbiage makes a difference. So in this case, if we add one data point exactly at the mean, right? Which ones will not change? Well, the mean will not change, and the range will not change. That's the distance from the high to the low. But these other ones might change because the median, maybe it moves it one way or another. Standard deviation, that will probably actually reduce the standard deviation because there's more data in the middle. And the interquartile range could then be reduced because of those. So, yeah, so I just kind of, an example, you could just write down a little data set like 1, 2, 3, 4, 7, and then add a data point that's right at the mean and see what it might actually happen. So you could do it and then figure out which of these change. So can be a tricky one. Most people get these with the messed up graphs. Like this one is twice the height and twice the length, but it's also twice the depth. So it looks 8 times bigger, even though it should only be 2 times bigger. So it's deceptive graphs that way. All right, let's go to page 2 here. Make this a little bigger. So describing these data sets, they both obviously have one dominant mound, so they're unimodal. And this one looks like it's skew right. Like imagine if it's a ski hill in which you're going to ski down the slope here, you'd ski right. And this one you would ski left. The other ones are kind of maybe too steep for a bad skier. So if it's skewed right, the skewness pulls the mean. So if it's skewed right, the mean gets pulled up. And if it's skewed left, the mean gets pulled down. So if it asks you which one's higher, the one here on the left, the mean would be higher. On the one on the right, the median would probably be higher. And if it's uniform, they're pretty much, or uniform or symmetric, it's pretty much the same. And that's what those 2 questions are asking. And then with some observations, you can say it looks like sales are higher on average. Yeah, so and it has a higher range. There's more spread. There's a higher average here because it's probably around over 40, and this one's a little under 40. Just some observation, and I pretty much count anything that's correct. Here's a good one. Who are the subjects? That's the people being studied. In this case, it's the students. What's the instrument? How are you measuring something? And that would be the exam here. And what are they testing on? They're testing on which one has a superior teaching method. And confounding variables are things that could mess with these results. And I put a whole bunch. Were they randomly selected? I don't even know. Does it say? Yeah. So there could be a bias in the sampling method, right? Because they weren't randomly put in these 2 classes. There could be difference in the teachers. There could be different demographic information based on these 2 classes. One's morning, one's afternoon. All these things, all these other factors may cause change that we're not measuring. So it can be confounding variables. How are we doing on page 2? Questions on 6 and 7.
I'm just a little confused on unimodal versus bimodal.
Yeah. So unimodal is obviously it's got one mound. A bimodal would look more like this, where you've got 2 distinct mounds. Or if there's even more than that, you call it multimodal. So for instance, a lot of times in this class, it happens. Like in statistics, the grades in this class look something like this. We got a whole bunch of people that are getting A's and B's, and then a few people get C's and D's, right? So there's not, and it seems like as this course goes on, it gets more and more split. It's like the have and the have-nots. There gets to be a split. So is that helpful?
Yeah, thank you.
Yep. All right, should I go on?
Yeah.
All right, so on this one, it's asking you to take and create a frequency table and a histogram. So it says create a frequency unit with 4 classes. So if you split the data into 4 classes, 1, 2, 3, right? So you can say there are 11 in that range, and there are 32 in this range, and 25. And then you can make this little histogram where the counts are on the frequencies are on the left, and on the horizontal, it's the values. And this definitely looks unimodal, probably a little skewed right, tails to the right. And then this one is a bimodal. So if you split it, exact same data, but you split it into 6 classes, right? 1, 2, 3, 4, 5, 6, and you do that, the data looks much different. It's the same data, but all of a sudden, it went from unimodal, kind of skewed right maybe, to bimodal. And this is to show you, sometimes the way you pick your bins or widths can make a difference and deceive you. So it asks you which one's better, which one's more depicted. So if you look at it, there's definitely like a mound here and a mound here, right? Right, like mound here and a mound here. So it's probably better to see the bimodal distribution. So I'd say the 6 classes is more representative. Make sure when you create your histograms, there's no gaps between the bars. Questions on that one?
So like for the drawings and stuff, do we get points for doing the drawings versus not doing them?
Yep. So you get, for instance, this one, I think it's 2 points for the correct histogram and a point for the descriptor.
Okay.
Yep.
So do we draw them out like online, or do we draw them out on like a piece of paper and then like submit them online with the test?
Piece of paper, just write them on a piece of paper. Yep.
Okay.
And then take a picture of it. I think I have had a few people type all of that into StatCrunch, but that's kind of time consuming and overkill. So yeah, just kind of do it like that. And here's now these are on like the empirical rule or just z-scores. So number 9, it gives you an average. It gives you the average for a day is $21,000. Today it was $16,230, obviously less than normal. If you find the z-score there, you get negative 1.33. If you look that one up in your Z calculator, that's about 9.2 percentile, right? It's low, but it's not statistically significantly low, because we'd say it has to be less than 5% or more than 2 standard deviations, or those standards are both usable at this point. And it says what would be, was it unusual? No, because it's greater than 5%. So questions on 9, does that seem okay? Similar to the discussion you did, right?
How did you calculate the percentile? Like the calculator? Because I need the 1.33. How do you convert that?
You just actually type that right in your normal calculator. Here, should I just do that? Where's that at? Here we go. So you want me to share my screen so you can see this again?
Yes, please.
Yeah, here we go. Hold on. All right, let me get back on it there. All right, let me. All right. So if I pull up my normal calculator, I can go stat calculators normal, and I can just type in, what was it, negative 1.33.
Yes.
There you go. How's that? So there's about 9.2 percentile, right, that are below that. And yeah, that's pretty much it. That's why I suggest just keep using the standard normal, and no matter what we do now or in the future, you just type in the z-score here and you're good.
So during the
It's just-
test, we can use all this stuff on StatCrunch.
Yep, yeah, it's right in the instructions too. It actually tells you to load it and get it ready. Yep. Yep, and you'll have that for all the tests. How's that sound?
Good.
All right, let me go back to here. All right, let me go back to that. Cool. And then number 10 is a little more in depth. It's very similar here. You find the Z-score. The average is 55. Their phone bill is 79. What's probably that's that or higher? That's 2 standard deviations above normal. If you look that up on your normal calculator, it's about 2.28%, or you could even estimate using the empirical rule and say it's 2.5%. I'm totally fine with that. And then what percentage are between 31 and 79? Well, we know 79 is 2 standard deviations above. And if we go to the area to the left, it's 97.72%. And then if we go 31 is 2 standard deviations below, which puts us at about 95%. I think that's actually, we got one too many zeros there, right there. Let me blank that out. Hold on. How's that? It says 0.028, which gives us, so about, and really even if you just recognize it, oh, what percent are between -2 and +2? It's about 95%. That'd be the right answer. You don't even need to use the Z tables on this. You can just use the empirical rule. And then this one is a little more tricky. Ones like this, there's a couple like this are actually going to be extra credit on your exam. So it says, what would be the cutoff for the top 5%? So now you could look up what's the Z-score for the top 5%, and that's 1.65. And you just type in 0.05 into the area part, hit compute, it gives you the Z-score. And then we don't know what that score is. We do know the mean. We do know the standard deviation. So we get the 1.65 from the Z calculator, 55 is the mean, 12 is the standard deviation, cross multiply, and then add 55. And then so any bill that's $74.80 or more would be in the top 5%. And that's about it.
So for 10, why
Yeah.
why is it that we don't have like the descriptors? It's just the picture. Like why don't we have to write like unimodal for that?
Oh, because if it's normally distributed, we already know it's unimodal and symmetric.
Okay.
Yeah. So it kind of tells you that if it's normal distribution, there's really nothing to describe. You just know it's this shape. Yep.
So I was looking at the formats for the other tests as well, and those look different compared to this one with like, I guess the formatting of it. Is this
Okay.
formatting closest to the actual test?
Yeah, I mean, I think they're all free response, right? And they all have some Z-score questions. They all have some sampling questions. They all have some histogram type questions, right? But yeah, this is pretty similar, I would say, to the one you're going to take. So if you feel comfortable with this, you're going to be just fine on the test. And do you want to go over a couple other ones on some other exams? I could just add
Go
them
over the
quick.
2019 one.
Sure.
Okay.
Let's see here. All right. So there's the 2019 one. So it's very similar. Is something rare or not, right? So if somebody had that that they've got a 1 in 10 chance of getting those results is that rare, and we're using kind of the 5% as our threshold. So if 1 in 10 is a 10% chance, that is not statistically rare. What's the best way to select? Again, random. This is a unimodal, skewed right. This one's a little different. It says, which of the following by adding one data point higher? It says might change by adding one data point higher than all the others. That would raise the mean. It might raise the median. It would raise the standard deviation. It would change the range, and it might, it probably would, yeah, it would change the interquartile range. Well, maybe, because you don't know if it's going to change the quartiles or not, because there could be multiples at those points. So, but if it said must change, if I picked one higher, the mean would for sure change. The median, not necessarily. Standard deviation, yes, because it's off the mean. Range, yes. Interquartile range, not for sure. So if that said must change, that would be a slightly different answer set. So that's a good one. So that's kind of similar to the last exam, right? So this one is what you expect. So if you see the median here and the min and the, so if you look at the 5-number survey, it says, what would you expect the mean salary to be higher or lower than the median? Explain. So this looks like, if you look, the distance from the median to the max, this is like what, 50-some thousand above, and this is only like 20,000 below. That tells me the data is skewed right. We got some data that's pulling it to the right, some extremely high maxes, which is going to move the mean that way. So it's going to be skewed right. So you can kind of look at the distance from the middle to the ends as a general way to check for skewness. Which one's more resistant to outliers? The median. So for instance, if I had one house that was $1 million, the median might actually stay exactly the same because it's just the middle house, right? The mean might go up quite a bit. So the mean does not resist outliers very well, but the median does. And then the range is pretty easy. Interquartile range is just a difference there, so that's pretty easy. What do you think about the so far?
Good so far.
Okay. Looks like 5, which is more appropriate. If you're going to experiment on humans, that could hurt them. Yeah, you might want to use observational studies and not purposely hurt people with experiments. If you want to get better results, like on a fertilizer plant growth, we can do experiments. Is this is this representative? No, because that's a voluntary response bias. Only people that get the magazine would respond, or it might be not representative of the population that you're trying to infer to. There's some confounding variables, kind of similar to the last one we did. What's the best way to do that? Randomly assigned. So this seems pretty similar to the last exam. Let's see. Here's a couple box and whisker plots, and which has the highest median, right there. Which one has the lowest median, right there. Which one is the most variable, the largest range? That would be the west. Which distribution is the most symmetric? That means the distance between these little quartiles is the most consistent. It looks like the northeast is the most symmetric, same top and bottom. And this one looks like it would be skewed high, and so this one not as bad, but a little more skewed high. But these both look like to be skewed to the high side. This one, they gave you raw data and kind of made you create a histogram, figure out your own ranges. Looks like I did one of 4 here and made a histogram. Looks like that would be unimodal, skewed right. And let's see here, this last page, these would be very similar, I think, to the ones we just did. Yep, find the z-score, look that z-score up. Is it unusual? Yes. What would be the percentile rank? I think there might have been a typo in this one. Is that why I accepted both answers? I can't remember. Oh, it should be 0.4 feet, not 4 feet. Standard deviation of 4 feet would be a lot for a basketball team. There's not that much variability in their height. So I think that was a typo. So I accepted both these answers. And 12, this is empirical rule stuff. 1 standard deviation above puts you at the 84th percentile. 3 standard deviations below essentially puts you at the 0.13 percentile. And so there's about 84% in between to find a difference. And how do you find if something's better? Well, which one's higher from normal? Find the z-scores. So a score of 92 on a test where the average is 71, a standard deviation is 15, that's 1.4 standard deviations above normal. A 688 on a test of 493 with the 150 standard deviation is 1.3. So actually the 92 is higher in rank compared to everybody who took the exam than a 688 on this one, on this exam. So the z-score can tell us, reference how far away from normal it is. And this one's an extra credit one, again, very similar. What's the equivalent score in the second exam? So if you take 1.3 standard deviations above normal and you use what score is the same, you just put 1.3 in for z. We don't know what the score is. We do know the mean. We do know the standard deviation, and we solve. And 90.5 would be the equivalent of a 688 on this other exam. So I would encourage you to yeah, go ahead.
So is there an extra credit question on our test or no?
Yeah, it's similar to this one. Yep. Yeah.
Okay.
So it's kind of next level. You know, can you go find a z-score for percentage and then do the math with it? We're gonna be doing a whole bunch more than the chapter 6, but I just sprinkle a few in here to get us thinking that way. It's not worth a lot. It's like worth 1 point, but you know, if you can do it, that's great already. You know, it's not gonna make or break you. So cool. So I just encourage you to go through all of them. Maybe even do one. Maybe you want to save one as a practice exam. But just what I've shown you right here is probably more than enough if you feel comfortable with these things. And yeah, just do it by midnight tomorrow night.
Awesome. Thank you very much for your time.
Oh yeah, no problem. This is great. Let's see here. Hold on. Okay, that's good. All right. So Rachel or Tanner, what do you think? Are you feeling pretty good about the exam and chapter 3 discussion? And
Yeah,
I'm
it's a
feeling
lot
pretty
better.
good.
Thank you.
okay, cool. Well, this is very helpful. I know not just to you, but to everybody else, because a lot of people can't be here at this time. So I'll be posting a recording of this for people to watch. So you can look for that email to come out here probably within an hour or so. I'll blast it out, and then maybe that'll help somebody else. And then if they have more questions, I can follow up with them. But if you want to do this again tomorrow, I'm totally cool with that as well. If you're wanting to do some more review, but yeah, I would just encourage, get your online homework and your discussion done today if you're able. Cool. Is that a gaming chair too, Rachel? Yeah. Mine's a office chair. Not as cool. Yeah. So what games are you guys into? Are these somebody else's chairs?
This is my chair. I do like racing games and like some shooters like Call of Duty, Rainbow Six, Siege.
Nice.
Just fun ones.
Rachel, how about you?
I'm not really even a gamer. My dad is just like super into like big gifts. And this was his most recent. So now I have this big chair.
Okay, well, I think ergonomically you won, so you're going to be just fine. That's funny. All right, well, you two are awesome. Thanks for being here. Text me, call me, set up an office hour, hit the Ask My Instructor button. So I'm readily available to help whenever you need it. Okay.
Thank you very much.
You
Thank
bet.
you.
Anytime. I look forward to seeing you guys again. Talk to you later.